Hello, APChem. What's up? So today I'm going to show you guys some stuff about chapter 16, I believe that, and there may be there might be like 2 classes this week on 2 classes this week that will relate to the AP from chapter 16, and then there's one more thing I have to show you on Wednesday on I think it's on chapter 17 or 18, but it's very quick and it shouldn't take too long. So you'll have kind of a 3-day thing. I'm probably gonna do another quiz because this is like literally the last thing that you have to do. So actually I could make it a test and then include everything that you just did and these things, but I probably wouldn't do it until next week, maybe on Tuesday or something like that. Not that you need a whole lot of time to study, but it'll probably be very similar to the last thing, which seemed to work out for most of you. So yeah, great work on the test, and so here is it's starting on the first little section of chapter 16. There's some terminology that I'm going to share with you guys today. The first thing is this term. So KSP, the SP stands for solubility product, and it's the equilibrium expression of typically something that is very, very insoluble. And so you remember how you learned the solubility chart, and I said, you know, AgCl, if you happen to see that in water, it would be a solid because it's not going to dissolve very well. Same thing with like any carbonates. What are the other ones? Chromates, very insoluble. Hydroxides are usually insoluble. So that the whole chart from the regions table, table F, I believe, is the solubility chart. Remember that I said you should memorize that. So the things that we consider to be insoluble are always, and this is kind of weird, they're always a little soluble. So if you ever see, and actually I could just use AgCl there, if you ever see something which it references a KSP, it usually means this particular compound is really insoluble, but it's soluble a little bit. And so if I said AgCl, so let's see here. AgCl has a KSP of 1.6 times 10 to the negative 10th. So remember how before we had done like acids like Kas and Kbs, and you had to know like what those reactions were. It's the same thing with KSPs. So here's how this works. So you say something like AgCl is a KSP of 1 times 10 to the negative 10th. What that means is if you dissolve AgCl, so AgCl solid, you throw some water in there, it'll look like this. Like all the AgCl will just be as a solid on the bottom, but you're gonna have like a few Ag pluses and Cl minuses kind of dissolved and surrounded by the water, but really, really small amount of those things. So, anyways, AgCl dissociates, it turns into Ag plus Cl minus, and in this case, if I said, well, what's your Kc? Well, the Kc of this reaction is called the KSP in this particular case. So solubility product is usually of insoluble insoluble salts dissolving dissolving a very small amount. And mathematically, you can actually calculate the KSP, and it is actually really helpful in a number of cases. So, so let me just show you the math surrounding this. One question might be, okay, here are the 3 questions that you'll get from this. Well, 4 questions. 3 questions. What is the molar solubility? What is the concentration of Ag plus or Cl minus? And then the last one is, what is the KSP? Like, these are the 3 questions that you'll see from KSP. And so, in this case, if I give you the KSP, so I'm going to erase all this stuff and show you. If I give you the KSP, I'll usually ask you for molar solubility or the concentration of Ag or Cl. So, here we go. You get a question saying, what is the molar solubility of AgCl? As I said before, it was 1.6 times 10 to the negative 10th. And, you know, I'll also throw in there, also, what is the Ag plus and Cl minus? I think you'll be kind of surprised by these answers. Okay, so what's going to happen is we take AgCl, and you pretty much always just do this, and you make this Ag plus AQ plus Cl minus AQ. And I usually put just like this big box because it represents, there's some solid there, but it's not really in, it is an ice table, but you don't really care about the amount of solid here unless they specifically ask you how much dissolved. And so it always goes like solid, 0, 0. Then you go minus x plus x plus x. Once again, you just go with the coefficients in front. And then you kind of just ignore this thing. This thing becomes nothing. And then these become x and x. So if your KSP is basically these things, don't divide by this because this is a solid. So you would just go Ag plus times Cl minus. So you'd go 1.6 times 10 to the negative 10th equals x times x. You solve for, it's probably going to be like 1.25 times 10 to the negative 10th. I'm going to guess. I love guessing. Let's see. This is exciting. What did I say? 1.25. No, I'm going to say 1.28 times 10 to the negative 10th. 1.26. Okay. So x equals 1.26 times 10 to the negative 5th. And so that tells you your equilibrium concentrations of Ag plus and Cl minus. So those answers are right there. And now here's the kicker. The molar solubility. This means when AgCl dissolves, what would its concentration be in molarity? And it turns out that it's always just this x. So this x is sort of your molar solubility. So once you solved for x, you've solved for your molar solubility. So actually, the answer to all 3 questions is 1.26 times 10 to the negative 5th. Now, let's get a little more complicated. What is molar solubility of Okay, let's try COOH3. By the way, if you wanted to see these things, they're all on page 643. All the KSPs. So, and we skipped over 15, chapter 15, because that's not on the AP. So, what is the molar solubility of COOH3 and the concentration of CO plus 3 and the concentration of OH minus? So, if you want to pause here and then guess what's going to happen, it's pretty straightforward. It's just like you think. You throw a water in there, you'd get a CO plus 3 AQ, because that's the charge of that, plus OH minus AQ, but this time you're going to throw a 3 in front of there, because you have 3 OHs. So we go box 0, 0, minus X plus 3X. Just note, molar solubility over here. So don't really care X and 3X. And then if you throw your KSP expression would be CO plus 3 times OH minus cubed. And you throw these values in, be really careful. Most people forget, like at one point or another, to not, they forget to put that 3 in there. It's going to be 3x cubed. So it's going to be x times 3x cubed. Oh, and I forgot to tell you the KSP of this one. KSP, very insoluble. 2.5 times 10 to the negative 43rd is your KSP. So super, super small. So now what we're going to do is we're going to say, all right, 2.5 times 10 to the negative 43rd. I'm going to do this out for you, but I know most of you are just going to throw this into the 89. But this is going to be 3 cubed is 27. So this is going to be 27x to the 4th equals that. Divide by 27. And we can go ahead and solve for x. So 2.5 times 10 to the negative 43rd divided by 27. Then the 4th root is 9.81 times 10 to the negative 12th. And now what you're going to do is you are then going to solve for the molar solubility. Well, you just did. So the molar solubility is 9.81 times 10 to the negative 12th. Then your CO plus 3 is 9.81 times 10 to the negative 12th. And the 3 times that is going to be 2.94 times 10 to the negative 11th is going to be your concentration of the OH minus. And that's probably a good starting point. I could do one more question. So if I gave you, let's see if I can find one here. Yeah, okay. So if I gave you the molar solubility and I said solve for the KSP, that seems to me to be like a little too easy, but if you wanted to try one like that, that would be on page 644, exercise 16.2. It basically takes up the whole top left stage, top left part. But let me make one more change and then but if you wanted to try that one, that's actually not a bad one to do. All right, one more question. And this one, okay. All right, I just have to calculate something really quickly. So we're going to say PbI2 is dissolved in water and has an I minus concentration at equilibrium of, and now I do have to do a little bit of calculating. Okay, now if I mess this up, it's, you know, of course my fault, but 0.00304, I think. So, I think I did that right. So, what you would do is, oh yeah, and then what is the KSP? So if you were going to stop the, you know, do it now and then come back and see if you get it right, this is the time. You would go PBI 2 solid water, PB plus 2 plus 2I minus, and you'd go box 0, 0 minus x plus 2x. Doesn't matter, x and 2x. You'd say your KSP is PB plus 2 times I minus squared. And then, now, they give you the concentration of I minus is 0.00304, which means that 2x is 0.00304. So therefore, if 2x equals 0.00304, x equals 0.00152. Which means x is 0.00152, and then throw that in here, so you'd end up with 0.00152 times 0.00304 squared, and let's see if I get it right. 0.00152 times 0.00304 squared. Yep. PBI 2. Yeah, 1.4 times 10 to the negative 8th, which is just what it was. Okay, so tomorrow we're going to do the common ion question, and then we're out of KSPs, and then we'll move on to a little bit of delta G and delta S, and then we're basically done with the year until the AP, and then after the AP, we'll just do more chemistry. Well, I want you guys to at least have the rest of the class, so, but I want to do a lot of review so that you're prepared for the AP. So, so any kind of quizzes or anything we do, I'll make it so that it's AP preparation. Okay. So, hopefully you guys got a pretty good handle on this and you can work through this today. And good luck, and I'll see you later. Miss you all.